So, welcome everyone. It's my pleasure to introduce today's speaker, Marilyn Walker, who is currently a professor at the University of Santa Cruz, both in the computer sciences as well as in the computational and media department. And she actually has roots at Stanford. She did her master's here in computer science, did her PhD in also in computer science. And since then, she worked actually both in industry for HP and also Bell Labs, as well as a professor here in the US, as well as in Europe. And for the last couple of years, basically, she is at the University of Santa Cruz, and her research interest is understanding and developing computational models of dialogue. And you can imagine whenever you interact with a computer, it's not only about information processing, it's also having some sort of a social interaction. You want to have a machine that maybe feels your own mood, but also has some sort of a personality coming back to you. And we all know this when we, call a company and on the phone we deal with a machine that is not very pleasant, right? And of course, these kind of dialogue systems are also important in games, and so it's a real pleasure to have her here. So welcome, Marilyn.
Pleased to meet you. I brought Stephanie Lucan with me, who's my PhD student who is working in this area. And Ingmar actually heard her give a talk when he was at Santa Cruz and invited me to give the talk here on that on that basis of hearing Stephanie talk. So some of the things, questions you might have, Stephanie might be better equipped to answer. So we can kind of, when we move into question period, I'm hoping that she'll come up here with me. So the general area that I'm going to talk about today, the technology underpinning a lot of the work I do, is called natural language generation. And I think a lot of people kind of generally know what natural language processing is, or text processing, but you might not be as familiar with the idea of natural language generation. So I just want to start with a little introduction. So natural language generation, it's a subfield of natural language processing, and the idea is that it aims to generate language from a deep semantic representation of meaning. And what they say about the difference between natural language generation, natural language processing is natural language processing is trying to count from 1 to infinity, but natural language generation is trying to count from infinity back to 1. So there's a lot of things about it that actually make it more challenging in many different ways than just the processing of the text. And there's lots of different applications of this. It's an area that's much more popular in Europe in the last few years as more and more texts have become online. A lot of the momentum and emphasis in the field has shifted more to the natural language processing side. So a lot of people that used to do work in generation now do like text summarization, which is a related area. But as more of these new applications come in, as people get more interested in AI and artificial agents and stuff, I think people are going to realize that there's a problem when the computer can't really say anything back, right? So it's going to get to the point where it can kind of understand everything that you can say, but everything that it has to say back to you is completely canned. And you're very quickly going to run out of its script, and you're going to be kind of bored with talking to it. So some of the application areas, like a classic application area for natural language generation that kind of goes way back, is this idea of report generation. So you have a database of information, and you want to generate that some kind of narratively structured text or some kind of report from it. And so that's kind of where there's a lot of business applications is kind of core now. But then, we've seen these films come out in a few years, this idea of, Siri and the AI and some kind of social interaction with agents. And the work that I'm going to talk about today, what we're doing is kind of more in this space, is we're trying to develop technology that could generate from a deep representation and actually have some kind of social presence. So to do that, we want to be able to generate lots of different variations in how the computer talks to you, how the agent talks to you. And because I'm not sure if everybody's familiar with this, but say like Siri is actually a script. It's like a movie script. What Siri says, so there's a state, and then there's what Siri's going to say in that state, and everything that Siri can say is already spelled out in advance. And what we're trying to do is, by using this deep representation of meaning, we're trying to generate utterances that can be tailored to the situation, the person that you're talking to, the mood of the speaker, the agent's personality, the agent's style, all these kinds of things. And in order to do that, we need to have this kind of procedural, parameterized model of how to generate language. And in work that has actually tested this kind of ability to generate linguistic variations, there's evidence that shows that you can be more effective at a task if you, for example, match the user's personality. So if you have a robotic exercise coach that matches the personality of the user, it can get people to do their exercises more reliably than one that doesn't match the personality of the user. So there's actual effects from the style of the speech onto the task effectiveness, which is kind of surprising maybe when you first think of it, but then if you think about people that you work well with and other kinds of things, it's very obvious that your own personal style and identity has a big effect on how well your collaborations work. So our goal is to kind of mimic this flexibility and adaptation in style with a generation engine that can be customized for lots of different applications. And what I'm going to talk about today is this work that we've done on generating variations in how you can tell a story. And one thing that we do that's really novel that we've just been working on for the last 2 years is that we reuse personal narratives that were posted on weblogs for the content. So instead of having the content like in weather report generation or other kinds of previous natural language generation applications, our content is this reuse of stories that have been posted on weblogs. And we think that this particular aspect of language generation will have particular applications for us. You can imagine, like, if you have a story about, how you broke your leg, and the agent says, oh yeah, I broke my leg once too, and this is, what happened to me, and it repurposes content from a breaking leg story on the web, that actually might be useful as a companion agent or to help you deal with the, frustration of not being able to get around or things like that. So here's a story. This isn't maybe one that would be such a therapeutic application. Here's a story of that we call the startled squirrel story. So this is a weblog that was posted where somebody's kind of looking out on their patio and they see this thing with a squirrel, right? So it starts off saying, I wish I had a digital camera. We have water bowl on the back deck for Benjamin, who's a dog, to drink out of when he's playing outside, and lots of other animals like this bowl of water. And then, we have this this little segue. The birds line up on the railing and wait their turn, and squirrels also come to drink out of it. The craziest squirrel just came by. He was literally jumping in fright at what I believe was his own reflection in the bowl. And then it goes on to tell this causal chain that the squirrel approaches the bowl, the squirrel sees its reflection in the bowl, the squirrel jumps, startled from seeing its reflection in the bowl, and it kind of falls off the deck, right? So that's like the narrative arc there that it's telling in this story. And in order to generate different versions of this story from this content, we need to have this a deep representation of the story structure, because remember, we're trying to generate back from a deep representation of meaning to different surface variations in form. And what we do for our underlying story representation, which I'll explain just a little bit more, is we use a formalism called a story intention graph. It was developed by David Elson, who did his thesis work at Columbia. And this formalism comes with an annotation tool that lets you annotate stories to generate this deep underlying representation, and it takes about an hour per story. Now, in n years' time, where n could be anything between 10 and 50, natural language processing might get to the point where it could automatically generate a deep representation like this just on the basis of doing processing. But since we're trying to work on the other side, where we're generating back, we're kind of looking forward to a day, when this would kind of all happen automatically, and we're producing this representation using the annotation tool that comes with the story intention graph formalism. So we don't just have this textual interpretation of the events like we would get when we first pull stuff off the weblog, but we also have these underlying deeper representations. And what you do when you do an annotation is you pick a piece of text, and then you pick using off-the-shelf lexical resources like VerbNet and WordNet. You instantiate the verb and the arguments of the verb with actual lexical items that you have that give you an anchor into a deep lexical representation of the meaning of the sentence. Then you proceed to do this interpretive layer. So you do that for a timeline underlying the story. And this is a chronological sequence of events. And then you specify some of these other relations between the events, like these causal chains, and also the interpretation of the kind of plans and goals, right? So when the squirrel approaches the bull, as soon as you read that, you get this inference in the context of the story that what the squirrel wants to do is to have a drink of water, right? That's never said in the text, but that's part of the deep representation. And so by the time we've spent an hour annotating a story where the story lengths are limited to less than 500 words from the corpus, we can have a deep representation like this for stories about anything from the web. Does anybody have a question about that part? No? And we have these relations between events like, that when the squirrel falls, it seizes its goal of drinking the water. And the reason the squirrel wanted to drink the water is to provide for the squirrel's health. So we have this affectual layer as well that kind of builds on like Maslow's hierarchy of needs and some other theories of like human actualization to say how people's goals affect their, why they might have that goal. So the goals can be things like your health, your ego, your pride, all kinds of things like that can underlie the story. And once we have a representation like this, we're in a position using an engine, a generation engine, which I'm going to explain a little bit more detail. We're in a position to generate different versions of the story than the original one. So here's a little example. I'm going to kind of foreshadow what I'm going to explain in more detail. So we have a system that can take that kind of representation as input and generate lots and lots of different outputs. And so here's an example. The baseline, what gets rendered just directly from the underlying annotation is, each point in the timeline gets rendered as a sentence using the verb that was used in the annotation. So we get the squirrel approached the bull, the squirrel was startled because it saw its own reflection, and the squirrel leapt because the squirrel was startled, right? So that's the kind of baseline. But we have a parameter where we can tell the story from the first-person perspective, from the perspective of the squirrel, or any other character in the story for that matter. We can move the point of view around, and we can get this variation where the squirrel says, that I approached the bull because I saw my reflection, I was startled, and then I leapt and I fell. So we can generate that automatically. And also we can color the output with what we can infer about the squirrel's mood on the basis of that deep representation. So these annotations here is that the squirrel felt fear, and that was why the squirrel was startled. And that when the squirrel fell, the squirrel felt despair because his goal of being able to drink the water had been interrupted, right? So we have these inferences about the character's mood and affectual responses to events also on the basis of that underlying representation. So that's just the first person. We have a whole bunch of different parameters that we can apply, and I'm going to explain how, right? But so we can use the first person in combination with, say, direct speech. So we can do a transformation. This is from a different story. The narrator said she didn't receive the new schedule. So we can do a transformation that has first person direct speech that says, I said I didn't receive the new schedule. And as soon as you get direct speech, you have to distinguish between the voice of the narrator and the voice of the speaker, of the character. So this opens up this opportunity to actually use a different voice, a different style of speaking for the narrator than you actually would use for the character. And each character can then have their own voice, right? So we have another whole line of work that develops different voices for characters as constellations of parameters. And this particular one is an extroverted voice model. Here's another story about a school teacher who's standing in front of the classroom and notices that her slip has fallen down to her ankles, and she has to kind of handle this situation with kind of poise, right, and not like leave herself vulnerable to a bunch of fourth graders starting to act up. So there's this story that she tells about, you know, I'm standing in front of the class, I look down at my ankle, I see that my slip is down on the floor, and I just carefully step out of the slip and I pick it up and I put it in the desk drawer and I just go on with my lecture, right? So that's this story, and we can, again, do the first person, but we could use an introverted voice model with the first person instead of the extroverted things. And some of the things that get introduced with this introverted voice model are some kinds of hesitations in the speech and some hedging, like that this, you know, is somewhat observed, and this kind of thing. And I resumed teaching. So, you know, it's not perfect. You know, our automatic generation mechanisms aren't perfect, but we can generate thousands and thousands and thousands of variations of any particular sentence in any particular story. So what we're doing in this particular project, which is Stephanie's thesis project, which she will be finishing in the next 6 months, is that we utilize this computational model of story content, which I explained, and it's coupled with an expressive natural language generation engine, which we can also use in other applications, not just in story. But what we had to do for the story domain, as it's a brand new novel domain for us that we've been working on just for a couple of years, we had to introduce these parameters that were narratively relevant, like the character voice, the first person, the direct speech. And there's a lot of motivation for these narrative parameters. If you look at the literature on story understanding, you know, there's evidence that shows that when people are listening to a narrative, for example, they follow along with the narrative events in their mind. They kind of enact these in their mind in a situation model. And if the story is told in first person with direct speech, you get greater activation when you're listening to the story than you do if it's told in third person without direct speech. So there's some very immediate cognitive impacts of stories being told in these different ways. So kind of what we want to do is we have this theoretical grounded representation of the story. We have this generator that uses these linguistic features. I'm going to show you how. We can translate from the representation of the story into the representation that our generator uses, because we use our generator for other applications as well. And then we've done some experiments where we collect the perceptions of the generated stories. We want to create a system that delivers the best variations, and we do this with statistical language training model. And then on top of all this, we're putting other kinds of variations that have to do with embodied agents. So we have a collaboration with Michael Neff at UC Davis, who's a human body animation expert. So we have an embodied version, a side project of Sichao Hu's thesis work, where we're using this same framework to generate embodied versions of the storytelling. And I hope I can get through most of this stuff. So here's this natural language generation architecture again. So this is kind of the basic architecture that's assumed to underlie any kind of natural language generation. So there's some kind of pool of content that comes from somewhere, like a database or some story world. And then you have some content planner that decides what of that content is going to actually be told. And it picks the content and it decides what structure it's going to represent it, right? So then it wants to introduce the characters and events and then start to tell the story. The sentence planner takes this stuff from the content planner and it creates these linguistic representations where you can decide like which content goes in which sentence, how many pieces of content go in each sentence, so you get different sentence lengths, whether you foreground or background information, who's the subject, who's the patient, all kinds of manipulations on the linguistic representation. And then you have a surface realizer. This can just be like a textual realizer, or it could actually be something that renders it on a body, right? So you have some kind of realization engine that takes these outputs and puts them out. So that's the kind of standard architecture. And when we started to apply this, so there's a classic distinction in theories of narrative between the fabula and the sujet. So that's this distinction that can actually be overlaid on this classic architecture for NLG, right? So, there's this notion that there's this narrative discourse, the diegesis, and the sujet is the actual telling of a sequence of events that constitutes the story. So this is how we visualize that mapping. And when we started working in this area, we weren't the first ones to observe this, or maybe not the only ones to observe this, but what we found is that lots of times the content pools that you would get from other places, like from a game, for example, like one of the games that one of my colleagues would develop at Santa Cruz, they don't actually have the information that we need in order to be able to render different versions of the story. So there's what's called this natural language generation and story gap. So there's like a story representation, but it's not rich enough. It doesn't have the information that you need. Like I showed you in our annotated version, we can't normally get that off the shelf. When we started this project, we're funded by NSF under the Creative IT program. And I was working very closely with Noah Wardrop-Froon on that. And we must have tried to get the information that we needed from like 3 different game systems at Santa Cruz. And finally, it just was clear that, this was something that, it wasn't something that they were thinking about when they designed the representation, and it didn't, however rich the representation was, it never kind of gave us what we needed in order to be able to systematically generate a lot of variations. And that's how we've ended up using this framework of David Elsons, where we annotate the text and produce our own deep representation of the story. So you can trust me, I'm not going to talk about any of this stuff in detail, but this NLG story gap had not really been addressed very well by any other work before we started doing this work a few years ago. And we've picked this story intention graph, and we really like it. We're really very, very happy with it. So we developed this new natural language generation architecture where we have this SIG story representation on this side, and then we have this whole translator thing that's customized for narrative, and it uses the same surface realizer that we had before, but we have this whole, it builds on what we've done before, but it's quite novel, and especially the most novel component is this ES translator, expressive story translator, that takes that deep representation of story and converts it into the linguistic representations that we need. And that's how we're filling this gap. Like I said, as part of that, I showed with these examples, we introduced a bunch of novel parameters that are specific for narrative. At this point, does anybody have any questions? Yes?
Can you talk about, so I noticed before you're taking these annotations and you're extracting kind of the emotion, right, like this fantasy fear. How, when you generate the audio, are you emulating that emotion? Is it just that you have, say, recordings of words in certain emotional states, or are you trying to dramatically emulate this emotion by, I don't know,
The new, we don't have a synthesizer that actually does exactly what we want. So we have, there's new HMM synthesizers, so we're a little bit ahead of the curve there. There's some synthesizers that have the underlying emotion segments and vocabulary, and then you can kind of modify them. But the quality of them is not as good as the I mean, I don't know how much you know about speech synthesis. Do you?
No, I don't know.
Okay, so the ways, the speech synthesizers that you hear now, like if you call and you get an artificial agent on the phone, they're based on a pretty simple technology of that you have this huge library of little teeny tiny segments of speech. And when you try to synthesize something, you build this huge network, and then you try to optimize all these different costs to decide exactly how you're going to render a particular thing. The only way it can generate speech that has emotion is if you have a whole library of those phonemes that are specialized for that emotion, right? So it's very kind of grunt, you know, it's brute force. It's a basic brute force mechanism. And the old speech synthesizers, like you would have had, say, like Stephen Hawking's voice, this kind of robotic synthesizer, they sounded robotic, but you could apply a whole bunch of different parameters, and you could actually try to make those synthesizers by warping the sound in different ways. You could make those express different emotions. So that kind of synthesizer kind of went out of favor around maybe 1996, when computers got fast enough to make this other thing tractable, that you could actually do this huge search and just do this brute force thing. And then it's taken a while for people to come back and say, hey, but we've lost this ability to do parameterization on the underlying models and actually produce different emotions. And so there's a new generation of synthesizers that combine those two approaches, but they're not good enough to use yet. Yeah?
Just to briefly describe, when you're making the story intention graph, how do you deal with ambiguity or interpretability?
The model says that there's not any one possible interpretation for a story, and that you can have many different interpretations, and that kind of fits with narrative theory, that any story can have many different interpretations. So we have some stories where we have different annotations with different interpretations, but in general, for our purposes, we're happy to have just one that works, that kind of captures the one meaning of the story. Okay, so I think I already said most of this already. You know, we really like this. I think if you read Elsons' Thesis, if you read the chapter, I think it's chapter 3 of his thesis, or chapter 4, I can't remember, where he kind of motivates this representation, this story intention graph. It's such a lovely piece of work. You know, it's really scholarly. He kind of reviews all the story representations that anybody has proposed for the last 50 years, and then he proceeds to say like what the weaknesses of each one of them are, and then he puts forward this representation. And then, so that's nice. It's got a really nice theoretical grounding. But then it comes with this tool, right, that naive annotators can use that let you build this representation for any kind of piece of story text. And it also comes with a library of a bunch of Aesop's fables that have already been annotated and represented with that. So it kind of gives you this whole package of stuff that kind of lets us get started on the generation side without having to deal with a lot of these other things. And what we've done is we've used that tool to build up this corpus of personal stories. So we hire undergraduate linguists mostly, but sometimes computer scientists. We hire them to do these story annotations for us. It takes about an hour to do a story. We go out against the blogs corpus. We pull out stories that have particular properties that we're interested in, like they're about particular topics, or they express particular affects. You know, we want to look for some like really negative stories or some really positive stories, and then we restrict the story length to be between 225 and 500 words. And so we get a whole bunch of stories that are kind of varied in terms of their topics and the affect that's being communicated, and they're short enough to be annotated with a deep story representation with about an hour of work by an undergraduate linguists, and we pay like $10 or $12 per story for annotation. So we're building up this corpus, and we have stories about all different kinds of things that we can build on. Okay, so under the hood, how do we generate these different variations? We need linguistic structure. We have to have linguistic structure to be able to generate from. And not only do we need it, but we think it's huge advantage to have it, and I'm going to show you why, right? So we need to get to these linguistic structures, and this is what's called like a dependency tree, attribute value matrix, where it specifies the underlying words and stuff for a sentence in terms of these, the lexical item, what class it is, what mood it is, indicative, right? So we have these, you're not going to be quizzed on this part later, okay? But we have this deep representation. And so, for example, the part about the left there is that, it's a verb, the lexeme is leap, and the tense is past. And we can automatically use these off-the-shelf dictionaries. The off-the-shelf dictionary knows that the past tense of leap is leapt. We don't have to say, like, generate leaped, and then say, oh, no, that's bad. Let's go in and fix the code, and say, oh, if the verb is, one of these things, it has an irregular past tense or anything. All we have to do is to change the tense from past to present or things like that, and the rest of the tool does the right thing for us, right? So that's one big advantage. Here's what the squirrel leapt. So we have the same thing, for the squirrel. We have a lexeme squirrel. We say it's singular, right? It's number singular. It's definite, right? So if we wanted to say the squirrels, if for some reason there was more than one squirrel, we would just say that it's not singular, it's plural. If we wanted to say a squirrel, we would just change the value of that article from being definite to being indefinite, and we would automatically get the right thing generated without messing around with a bunch of string manipulations. So so then for like our point of view parameter, which I told you before we're going to have, what we do is, we have the squirrel leapt, and it has person is kind of not specified. But when we want it to be first person, all we do is we add this person is first feature to the underlying representation, and we're able to get I leapt. Okay, so we have this translator that we developed that then goes from the story intention graph to this surface linguistic representation. I'm just going to try to go through this very quickly. So we have a deep representation of the meaning, like that the action is that the squirrel leapt, and that the squirrel leapt because the squirrel saw his reflection, right? So we have this deep representation in the story intention graph, and from that we get this, this syntactic structure that says that the main verb is leap, that the noun is the squirrel, that we have a prepositional phrase, right? So we get that from the story intention graph, and then we convert that into this surface realization structure that can be fed to the surface realizer that we have, and then the output just comes out. And this is described in this paper. So we get a squirrel leapt because it saw its own reflection. We can also do all kinds of stuff with sentence planning, where we can change the order of the underlying sentences and how they're connected together. So this is an example of sentence planning where we can change the surface form of the sentences. We also, we talked already about point of view. We can tell a whole story from the squirrel's point of view. And we can also do the direct speech. So like I said, we have these different voices that we can do. And we can, we take this deep underlying representation and we split it into these two subtrees, where this one's the one that's going to be realized as direct speech. And then we can apply a different model of style to that embedded direct speech so that we can get different character voices. So here's an example from a story where somebody showed up for a job interview. and the manager says to them, you were supposed to be here yesterday, and the interviewee says, no, I followed the online schedule. The schedule says I'm supposed to be here today, and so there's this whole interaction, and we can tell that story in several different ways, with a single narrator realization or as a dialogic realization between the two characters that are involved. When we've done experiments on this, we're still in the process of doing a lot of experiments, but we get these both qualitative and quantitative differences in people's evaluations of the story. So readers, I think not maybe surprisingly, but we still had to show it, readers prefer to read the story in the first person. Like I said, there's cognitive experiments that show that having the story told in the first person engages your mind in a different way, that you simulate the story more when it's told in first person in your own mind. We also get comments about the changes in voice, where we have a voice that's really outgoing or extroverted or about shy, and we get people that notice it and they definitely comment on it. And then we have this very new thing, which we haven't really quite fully developed and we haven't really experimented with yet, but this of modeling emotions. So the idea with this is that we can use the underlying representation of the story intention graph to produce these different emotional responses. So we know which actions are desirable and which actions are undesirable from the story intention graph, and we can tell whether it's a certain event or an uncertain event. And using the appraisal theory, this kind of directly gives us these different emotions that the characters should have. So we can run over that underlying graph and we can assign these emotions to each of the different events. So here's an example that Stephanie loves. The narrator, it's a story about how the person is woken up from sound sleep by some huge group of bugs in their house, right? So there's all these bugs in the house that were kind of attracted by the light. And so when you think about the emotions of this, the narrator's woken up, the narrator wants to kill these bugs, right? But if you think about it from the perspective of the bugs obviously they don't want to be killed. So the idea is like that the narrator has a goal, to kill these bugs and be able to go back to sleep. So that when the narrator forms the intention of killing the bugs with this rolled up newspaper, the narrator feels hope according to appraisal theory. They have a goal and they think they're going to be able to achieve it and that it's going to be good for them. So the narrator is kind of hopeful. But the bugs, if you look at it from the perspective of the bug, if the bug knows that the narrator's got this rolled up newspaper and is trying to kill them, the bugs should be feeling despair, right? So you get this kind of difference in the emotional state of the different characters, which you can infer from the underlying structure of the narrative, and you get this kind of differences in these emotional trajectories, where the narrator starts off being hopeful that he's going to kill these bugs, and the bugs, feel fear that they're going to be killed. And then if the narrator succeeds, the narrator's very, very happy, but the bugs are very obviously unhappy that they kind of met their device. So we have all these kind of different things that we're putting together, that we're playing around with. And we're putting this whole group of parameters together. These are some experiments that Stephanie is just running now, where we have all these different parameters, and we can generate many, many, many different variations, and we're applying what's called a statistical ranking model. So you have it's called over-generating rank. You have the generator produce many, many possible different tellings of a story or some part of a story. You have some kind of objective function that you're trying to maximize, like narrative, reader engagement, or narrative transportation, or coherence of the story, or how, it could be anything, any objective function. In this particular case, we're interested in the engagement of the reader in the story. And then you you run a user evaluation on these different outputs, you get your objective function, your user evaluation scores, and then you figure out how to choose among these parameters in a way that will optimize this score using a statistical learning method. So that's kind of what we're in the middle of doing right now. So how am I on time? Okay. So I just want to talk a little bit about some other stuff that we're doing that is kind of work in progress, some of which we have published on, and some of which is stuff that we're kind of doing right now. So given this is also pretty novel. So given this deep representation of story and these 108 stories that we've had annotated so far, we still have undergrads working for us. We've started to explore whether we could automatically generate dialogic tellings of certain stories from this same underlying representation. And this is the squirrel story. So I don't know how much sense you'll be able to make out of this, right? But basically, we have all these different features that control a dialogic generation. So what we do is we take the content of the story from the story intention graph, and we allocate it to two different speakers. First of all, you have to pick a story where it's reasonable to assume that two people could have participated in the event, right? Like two people could have been there watching the squirrel fall off the deck, or two people could have been there at a protest, or two people were there at a story. And what we're trying to model here is kind of an oral narrative tradition where when you have some kind of thing that's happened where multiple people were present, say like when you're talking about a story like around a family dinner table or something like that, the story is not usually told by one teller, right? If multiple people have been there, people are talking, they're interrupting each other, they're correcting each other. No, that's not what happened, right? So there's a kind of oral narrative tradition that we're trying to see whether we can actually produce stuff that starts to approximate some kind of oral narrative. And so, like I said, we take the story intention graph and we allocate the content between two speakers. And obviously there's lots of different ways that you could do that, right? You could give one speaker all the, semantic content, and the other speaker is just supposed to produce evaluations of the content or ask questions, or you can have them both, equally describe the events that happen. I mean, there's lots of different ways to do it, right? So that's a parameter, it's how the content gets allocated. But the bottom line is basically you just want to split it between two people so that they both have stuff to say. And so, here's this squirrel story kind of split between two speakers. And then we have all these features about the different realizations of the story that have things like, whether people repeat what each other said, whether you give an emotional reaction to what the other person said, whether you ask a question about what the other person said, right? There's all these different things that we use to convert a monologic telling into something that's more like an oral narrative, like a dialogue. And the way our generation engine is set up is that for each of these sets of parameters, we have some variance in there about how it gets realized. So each set of parameters, not only do we now have all these parameters where each combination of parameter settings generates lots of different variations, but also in any particular rendering, there's a little bit of randomness in there so that you don't always get the same thing even from a particular constellation of parameters. So, so this is like one rendering that you would get from this kind of set of parameters, which I don't think you can probably understand very well. And then we get these other, here's two other renderings that we get from the same thing because there's this kind of randomness in it. So this is something that I have an undergrad who started working on this at the beginning of last summer and kind of really surprised me that he was able, I kept saying to him, this is a really hard project. Nobody's ever done it before. And I'm not sure, if you really want to do this for your research experience for undergrads because, you might not be able to bring it to fruition. It's kind of complicated and there's only a few things that have been done like this, and it's all been done in expository settings where it's kind of like a Socratic model where people ask questions about, teaching content and stuff, and nobody's ever done it in this story way and all this kind of stuff. And anyway, he really surprised me, and we now have, like whatever it is, however many, 7 months later or something like that, we have this engine that actually, it works pretty good. It still has bugs in it, and it interacts with all the new parameters for the narrative that Stephanie has developed and does this dialogic rendering. I also have another PhD student, Grace Lynn, where we learn statistical models of character speaking style from film and from serials like Friends. So we have these statistical character models that we can apply along with the personality models to get these different character voices. So Grace and Kevin have been working together on this dialogue stuff, and I'm going to try to wrap up a little bit. We also have this corpus that we've developed where we created a human top line for these multi-agent renderings where we do like a markup. We generate the dialogic text, then we mark it up for where a gesture can happen and what the form of the gesture is. And then we, let me just show you, because I think I should leave some time for questions. We have this database, so as I said before, we have a collaboration with Michael Neff at UC Davis, who's a human body animation. We have these this gestural annotation that we put on there. Hopefully, sometime in the future, we will be able to mark up the gesture form and position automatically. Right now, we have to do it by hand, but once we have that, let me show you. Just given the form of the gesture and the placement of the gesture, we have all these parameters that let the agent tell the story in different ways based on those annotations. So this shows, like for an introverted or an extroverted agent, some of the parameters that are from the psychology literature that says how people's body language differs depending on their personality, and we have control over those parameters at the graphical rendering level. So I was just going to show you kind of a little bit what they look like. We can control, let's see if I can do this. We can control the speed. That's slower, you see. And we can control the scale of the gesture with the body. So we have all these different and then this is kind of examples of some of the parameters.
That was one hell of a storm.
Yeah, it was the biggest storm ever to hit that in Rouge.
The entire city was out of power for a few days.
I know. It took 7 days for power to be restored in my neighborhood.
The damage was pretty widespread across all of the neighborhoods in Baton Rouge. The wind mangled so many of the storefronts and signs. It also knocked over the trees and ruined a huge number of houses and power lines. So we've done some experiments on these gestural renderings to kind of check whether whether some of the things, this gives us an experimental paradigm where we can look at the gestural expression of personality and also what happens when speakers adapt to one another and do other kinds of things like people do in dialogue. And so we've done some experiments on this kind of stuff and shown that, people can perceive, like if you start off with an introverted and an extroverted speaker, and the introverted speaker starts to become more extroverted over time, that, people can actually perceive that there's this adaptation going on.